and due to our school teacher, we have to make this change. But now, as these are two sister chapters, we have to complete them together. Microwaves, stationary waves in microwaves. Stationary waves in microwaves. Microwaves are man-made low-frequency electromagnetic waves. How we can produce them, that's our first title to understand. Microwaves are those which are in our microwave oven. They are those waves which are our mobile phones are using. We use a transmitter and a probe. We use a transmitter to generate microwaves, and we have a probe like antenna which we use in our cars, like an antenna which is facing a reflecting sheet. What happened? Microwave transmitter is here. The waves go forward, they strike and come back, and when they come back, they superimpose on each other. This produces a stationary wave. Now look at this, the apparatus. The apparatus is here, and this apparatus shows how you can demonstrate stationary waves in microwaves. You have to give a side heading apparatus. You have to give a side heading apparatus, and you have to copy this whole screen.
Done, sir.
This is our starting topic for today, and we have launched a transmitter. Transmitter will send a signal to the reflecting surface. Signal bounces back and comes back. When the signal comes back, it superimposes with itself, and this is called stationary wave. Now, how we determine the wavelength from the standing wave? Now, we add a meter rule along the apparatus, and we have a meter with the probe. Remember that microwaves are not visible to us, so we need a meter, and meter can show the intensity of the microwave. So you have added a meter rule, and you have to move the probe along with the meter rule. So improve the diagram, copy this also.
Done, sir.
Now, I have added some more features. Now, what's my plan? I will be moving this probe along the meter rule at a constant speed. Now, you remember that there are nodes and anti-nodes in this system. There are nodes and anti-node in this system, and node and anti-node are actually meaning as maxima and minima. Maxima and minima. So after updating this diagram, you have to write under it the give us side heading working. Give us side heading working. The probe is moved along the meter rule at a constant speed. We move the probe along with the meter rule, and we the probe will detect alternate maxima maxima means antinode and minima. The probe will detect alternate maxima and minima, antinode and node. You have to copy this.
Done, sir.
Right. Now look at this diagram. The probe, we will move the probe along the meter rule. The probe will detect maxima and minima, and we have to mark two successive maxima or successive minima, two node or antinode. Our plan is to mark their positions because we can use these positions to determine the wavelength. So after writing this, you have to write under it that the separation between two successive maxima and minima, two successive maxima and minima, two successive maxima or minima are identified and the separation is noted by the meter rule. So this is the procedure. Copy this also. So we improve our diagram after this procedure. Look at this diagram. After improving this diagram, you can see that the probe will be moving along the meter rule. And now you can see the positions of antinodes and nodes. You will notice these two positions on a meter rule, and you will identify this separation on the meter rule. Remember this concept that this separation is half of lambda. You have to copy this. Oh, sorry, update it.
So what does D stand for?
Sorry, D is the separation. No? D is the distance. Distance between two successive maxima or minima.
Okay, sir, thank you. Done, sir.
So the plan, first you set up the apparatus, then you have to find two maxima, successive maxima or successive minima. You will have to move the meter rule. You have to move the probe along the meter rule. Then you will find the distance between two maxima or two minima. that distance is actually half of lambda, because two successive antinode or node is always lambda by 2. This is the fundamental apparatus, and you will move the probe along with the meter rule. Separation between two successive node is lambda by 2. Now, if you notice that the intensity will move like this. Intensity will be minimum, it will go maximum, it will go minimum, it will go maximum, like this. So intensity will move like this. You have to copy this.
Done, sir.
Sir.
Intensity is maximum at antinode and minimum at node. So you can use this apparatus and you can find the wavelength by this apparatus. So right under it, this method can be used to determine the wavelength. This method can be used to determine the wavelength. Now give a new heading, determination of the wavelength of sound by a stationary wave.
So standing wave is stationary wave, yeah?
Standing wave is second name for stationary wave.
Understood, sir. Thank you.
Now, after the success of the microwave experiment, then they start thinking on another experiment, and they were thinking that let's try this concept on sound, because sound is a very important wave phenomena, and they were looking for a long time that how we can find the wavelength of sound.
By frequency divided by velocity divided by frequency.
So apparatus approach is the same, but first we discuss the first method. This is called the method of dust piles. Dust piles are actually dust piles are used to demonstrate the waves, the stationary wave, because stationary waves are able to pick up the dust particles. So they thought about a plan. And what was the plan? That they thought that let's use sound waves by a speaker, loudspeaker. Look at this is a speaker. And they generated sound waves like this. Now let's strike from here. And it comes like this. So this is the idea that a stationary wave is produced within the tube. A stationary wave is produced within the tube, and the loudspeaker is able to send the sound signals. The sound signals rebound from the other end of the tube, and they form a stationary wave, where the stationary waves form nodes. Node means zero amplitude. The dust particles will be stationary like heaps. A very interesting diagram to see. The dust particles will be suspended. Dust particles will be suspended in the tube. Now you have to give a side heading, method number 1. Method number 1, and so write under it that a signal generator is used. That a signal generator is used to generate sound waves of known frequency. Sound waves of known frequency these waves strike from the closed end. These waves strike from the closed end of the tube and form a stationary signal. And form a stationary signal. Now you have to copy this apparatus. I'm just coming. Please copy down this apparatus.
Done, sir. Answer.
This is the real apparatus, and you can see a loudspeaker. You people can see a loudspeaker and a very well-known device, oscilloscope. Oscilloscope is actually CRO, cathode ray oscilloscope. And sound waves are produced by the loudspeaker. Microphone is there. Microphone is there to attend the reflected signal. The plan is the same. The plan is the same as the microwaves that will cause a reflection. The loudspeaker will generate a sound signal. It will rebound from the plane surface and superposition occurs. Same procedure. Then we have a probe. This time the probe would be a microphone. We will move the probe. We will move the probe along with the meter rule, and we will detect node and antinode. Node will be a zero sound, silence, and antinode will be a maximum sound signal, high intensity sound signal. So between the signals, between the two nodes or antinode, you detect the position, subtract them, and find the overall separation. Lambda would be double of that separation. You have to now copy this screen. Sorry, method number 2. I'm sorry. First, give a side heading. Method number 2. Give a side heading, method number 2, and then copy this screen.
Why is there a probe?
Probe, because sound waves, for that you need a probe like a microphone, so you can take up the signal and put it on the CRO. So
Okay,
probe is
so
just like when I'm talking to you, I need a microphone, so my sound signal can be picked.
okay.
Because themselves the sound signals are not transferable. You can't, and you can see the intensity of a signal.
So this is in like a tube, yeah?
No. Make it clear. There was a tube experiment. This was method 1, and this is method 2. Method 2 is very similar to the microwave experiment.
Okay, sir.
There are two separate methods. The tube experiment was for the heaps, sound heaps.
Done, sir.
Right.
Done, sir.
Now look at this graph again. Now this time it's a sound signal, and anti-node is the maximum intensity and node is the zero intensity. You have to copy this. This time it is for a sound signal.
Sir, isn't it the same thing as the microwaves?
Bilkul, definitely. This is what I'm saying. This experiment is similar to what they did for microwave. After the success of that experiment, they tried the same thing.
Okay, so what's the difference?
Difference is the nature. Microwaves are electromagnetic and sound waves are mechanical longitudinal waves.
Okay. Done, sir.
Done, sir.
Stationary or standing waves in air columns. But remember this concept strongly, that the main idea is the same, that we establish a stationary wave. And we move the probe and we locate the two successive we locate the two successive wavelength, two successive node or antinode, and then we double it. We double the wave, double the distance, that will be giving us lambda. So both methods are giving us the value of lambda. Give the heading. Now I need a break and I will extend the class as mentioned in the message because we have to accommodate the namaz times. So I'm coming in just like maximum 10 minutes, and you people have to copy this heading, and then there is a short namaz break. Okay, thank you. We are resuming our class, and we were discussing, we had given this heading, stationary or standing waves in air columns. There are two types of air column. One is called closed pipe and second is called open pipe. You have to copy this.
Answer.
Air columns are like many musical instruments. Many musical instruments use air columns. Air basically is a soft medium. For example, this is called a closed pipe. This is a very famous instrument, which is mouth organ. Mouth organ. And this instrument is capable of producing musical note if you blow air in it. This is a musical instrument. So after copying the list, right under it, the most common example, of air column, the most common example of air column are musical instruments. Are musical instruments. You have to copy. Now give the heading, close pipe.
Done, sir.
Closed pipe is that which is open from one end, like the test tube in our laboratories and our drinking water glasses. These are closed pipe. Now look at this screen. The incident signal strike the closed end and rebound. This forms a stationary wave. Remember, stationary wave is formed when the incident and reflected progressive wave superimpose. So give the heading closed pipe and then copy this screen.
This is an open end.
This is called a closed pipe. It is open on one side and closed on the other, like our like our test tube, drinking water glasses, like that.
Okay. Done, sir.
This is the concept of stationary wave. Now you can test it when you have a chance of you have a normally some pens have a lid, a bigger cap. So if you blow air in the cap, if you have a whistle, you blow air in the whistle, or if you have a test tube and you gently blow air in it, you will get a sound, a particular sound, which is the stationary signal. Now, as I mentioned when we were discussing stretch strings, L is equal to lambda upon 4. L is equal to lambda upon 4. It's a stationary wave. This is called the fundamental node. There is always a node. There is always a node on the closed end. And there is always an antinode on the open end. So L is equal to lambda by 4, and you can rearrange it. So you have already copied this diagram. So you have to update it and copy this calculation also.
Done, sir.
Good.
Done, sir.
Now I have a question, which is a very important thing in the paper. How come L is equal to lambda by 4? How come L is equal to lambda upon 4?
Sir, it's because there's only half of an antinode.
There is always a node and an antinode. Look, node to node separation is lambda by 2. What would be the separation when it is node to antinode? Node to node is always lambda by 4, and node to antinode is always lambda by 4. This is a very important concept. There is always a node at the closed end of the tube. There is always a node at the close end of the tube. You have to copy this also. Now, the most important concept which I want to repeat, which needs a very good understanding, critical importance is there, is the concept that how we determine this distance, lambda by 2, lambda by 4, etc. Now you have to learn this concept that we have a node and antinode. So remember this concept that separation between node is always lambda by 2. separation between node and anti-node is always lambda by 4. Just let me correct it, lambda by 4. Now you have to learn, everyone has to learn this very important property. Remember, node to node is lambda by 2 and node to anti-node is always lambda by 4. So whenever you come across a question like that, like now look at this one, node to anti-node is lambda by 4. Node to anti-node is lambda by 4. Now, if I take first overtone, now you people have to tell me how come it is 3 upon 4 lambda? How come it is 3 upon 4 lambda? Node to node lambda by 2, node to node lambda by 2, and node to anti-node is lambda by 4. So lambda upon 2 plus lambda upon 4, that will be equal to the length. Now you have to remember this very important concept. You have to copy this, this also in your notes. Now, reinforce this very important concept, which is the critical concept in this chapter. If you have a node, then anti-node, and then node. Now, remember this very strongly, that separation between two successive nodes is lambda by 2. And separation between node and anti-node is lambda by 4. Now you have to copy this.
Answer.
Now I go for my first overtone. The fundamental was done. This concept comes whenever this topic is there. Whenever this topic comes, this concept is there, that what is the length in terms of lambda? What is the length in terms of lambda? Now you have to copy this screen neatly.
Answer.
In this way, we can extend the fundamental note is lambda by 4. The first overtone is 3 lambda by 4. As I mentioned earlier, the main thing is to locate the number of notes, the number of antinodes, and remember this very important rule that note to note is lambda by 2. If you somehow learn this thing, you can do any question. Now, no need to copy this. I would like to ask that why the separation is 5/4 lambda. Just observe this. This is called second overtone. There is a 2.5 loops. Now, my question is why the length is 5/4 lambda. Yes, I'm waiting for the answer.
5/4 lambda is because there's one quarter of a lambda and one full lambda, sir.
And if you count node to node, lambda by 2, another node to node, another lambda by 2, then there is a node to antinode, then it is a quarter lambda. So lambda by 4 plus lambda by 2 plus lambda by 2. And as I mentioned, in this area of the syllabus, it's a very important calculation. Now, you have to mention this. Actually, it's our convention that if something is not in our course, we have to mention that because this is not a very old thing. It was in our syllabus. Now they have removed it, and definitely you will find the past paper on it. End correction used to look like this C. Look at this C, this one. This is called end correction. Now, end correction is not in our course, and you have to update it because when you do the past paper, you will definitely get questions like that. So you have to copy this screen.
Done, sir.
Done, sir.
Good. So we stop here and we will now continue this inshallah in our next class. Allah Hafiz.
Hafiz, sir.
Done, sir.